Well, what is basically kinematics? Actually, see, kinematics means it is the branch of that one. We discuss the motion of a particle, okay, without discussing the cause of motion, actually, okay. If we discuss the cause of motion, it will be a laws of motion chapter, okay, dynamics. But we are discussing only the behavior of the particles like velocity, displacement, distance, all these things, without knowing who is throwing it, okay, what forces applied due in the throwing. We do not concern about that. So okay, if we discuss the motion of a particle without discussing the cause of motion, then it is called that one kinematics, okay. So this is basically the definition. I think you should better write also in one sentence only, okay. Kinematics is a branch of mechanics which is concerned with the study of motion without really worrying about the cause of motion, without really worrying about the cause of motion. So basically in kinematics, what are the concepts we discuss? That is very important. You see, we have to study a chapter dividing it into some concepts, okay. In vectors also we have concept. Say what is the definition of vectors, what is the difference between vector and scalar. Then we discuss about types of vector, na? Then we discuss addition of vectors. We have three types of addition of vectors. Then we discuss dot product, we discuss cross product. In cross product also we have basically discussed three sub concepts. So exactly that way in kinematics also we are having some concepts, okay. So what are the concepts basically? See, first we discuss concept number one, what is distance, what is displacement, okay. That's very important, and today's class will be focused on this only, okay. Today we will be knowing what is distance and what is displacement, how we can calculate it properly, okay, up to that competition's point of view, okay. Then in the next class hopefully it will be discussed speed and velocity. Then we'll discuss acceleration in details. Then we'll solve some problems of that one graph, okay. That problems of kinematics with graph, okay. Then equation of motion for constant acceleration, that is of course you have done something in the class 9 also. Motion under gravity also you have done in 9, but we'll go beyond that. Then two-dimensional motion, okay. Up till now actually it was motion in one dimensional, but then we go for two-dimensional like projectile motion. It means simultaneously if x coordinate and y coordinate both are changing, then we call it two-dimensional motion, na? Projectile motion under gravity, relative motion, curvilinear motion means circular motion like this, na? We are going to discuss all these things, okay. Now actually don't no need to put all these things, okay. Just I have given you the idea. It means we can cover the chapter with these 10 concepts, but in one concept also 2-3 sub concepts may be there, okay. Depending upon that we are going to discuss step by step. So at the very beginning we are going to discuss in today's class, we are going to dedicate for distance and displacement. Koi doubt, for any doubt, please feel free to ask me any questions, okay. So distance, let us discuss. Please write down. Motion in one dimension, basically we are today's concept is distance and displacement. You please reading of the chapter, okay. Motion in one dimension, it means if only one coordinate is enough to explain it, then it is called one dimensional motion. And basically what concept we are going to discuss? Concept number one, distance and displacement. So what is distance? Try to understand. See, say I have to go from A to B through a zigzag motion as shown in the figure. Say from your home to school you go, the path is not a straight line. No? Your motion is not unidirectional motion. It may be a zigzag one, okay? So what is distance? The distance is the exact path length, okay? Exact path length, say 10 meter, 20 meter, like that you keep on counting. The exact path length is called the distance. Well, so you please write down that one definition of distance. The actual path length traveled by a moving body is called distance, okay? Distance has no definite direction, na? So it is a scalar quantity, and no need to show that SI unit of distance will be meter only. Na? Well, you please keep on writing, okay? simultaneously. Huh? Along with me, actually, you should keep on writing. Okay. Listen it also properly, understand it also, and write also. Okay. Then what will happen? You see, SI unit meter, and it is a scalar quantity. So we have already discussed in that on earlier chapter. Okay, the scale, what are the behavior of scalar quantities, what are the properties of scalar quantities. So see, say a particle is moving. Okay, say a particle is moving. Can its distance decrease? What do you think? Can its distance decrease with time, or its distance will keep on increasing only? If I want to calculate only the path length, so think and try to answer. For a moving particle, whether the distance keeps on increasing only, or it can decrease also, because it is the actual path length only. Because it is the actual path length only. So distance traveled by a moving particle will never decrease. Okay, it will always keep on increasing. But if it is stationary, then of course distance is fixed, constant. But if it starts moving, if it is coming back also, then also the distance is going on, will go on increasing only. Say a particle is going from a particle is say going from here to here. Okay, now it is coming back. So then also distance is going on increasing only. So first this much distance, then this much distance it is covering. Okay, it is not, it will not decrease. Then we can say that distance for a moving particle, distance never be zero. If it is moving, if it is stationary, distance may be zero. Distance will be zero. So it is not moving at all. But if it is moving, so definitely distance cannot be zero. Okay, and distance cannot be negative also. It is always positive only, because it is not vector quantity, it is scalar quantity. So though the direction is opposite, then also we do not take distance as negative. Okay, so if it is going right this, if it is +5, say it is coming back, so it will be not -5, then also we have to take only +5 only. Say 5 meter going, 5 meter coming, so total is 10 meter. But in case of displacement, it will be not like that. Okay, so we'll discuss all these things. So distance can never be negative. Huh? It is always positive. It is always positive. If the particle is not moving, distance may be zero. If it is moving, then distance keep on increasing and always positive. It cannot be negative. So these are the points from where question may arise. Are you getting my point? So get ready. Lot of questions are there in H. Verma concept of physics also, just on that only. So I hope all the 3 students, you understood. Anything left to be understood? Do you have any
No,
question
sir.
in mind? Okay, okay.
No, sir.
Nice. Then we are going to discuss about the displacement. Remember, displacement is something else. Distance is the exact path length, but displacement is what? Initial point and final point. Join it. The shortest distance, the straight line, the shortest distance from the initial point to the final point is called the displacement. Okay, say this is the same path I am taking, A to B only, a zigzag path. So distance we have already discussed, but what will be the displacement? Only the shortest path length. Directly join the starting point and join the final point. Okay, say if the particle becomes stationary at this point, so displacement will be this much only. If the particle rests at this point, if the final position is this, then the displacement will be this. If the final position is B, then the displacement will be this. Okay, actually the particle itself is covering the distance, making the distance only. Okay, displacement is automatically formatted. Okay, displacement is automatically formatted. So what will be the definition of that one? Displacement. You please write down. So this is displacement is a vector obtained by joining the initial position of the particle to the final position. Say initially the particle is at say x initial, okay? It's say the particle is moving along, displacement is along x-axis only, okay? It may be y also, no problem. And the final position is say x final. The displacement is always final position vector minus initial position vector, okay? So this is the basic vector definition of displacement. Similarly, actually, okay, here already we have discussed displacement is vector quantity because it follows the vector law and it has a definite direction, okay? That is why. And SI unit is meter only, okay? Similar to that one. So in this case, okay, similar thing we are going to discuss, okay, all these things. Whether for a moving particle, displacement always positive, or it may be zero, or it may be negative, okay? I'm going to ask you all these things. And just you please write down, it is a vector quantity and it's a scalar. SI unit is meter only, okay? Now, think of that, okay? Whether moving particle, for a moving particle, can the displacement be zero?
Yes, sir.
Yes, yes. If it comes back to the original position, so for a moving particle, displacement may be positive also if it is going towards positive x-axis, zero also if it is coming back to the original point, even it can be negative also, okay? If it crosses the that one origin, okay? Say this is the origin. Say this is origin. If the particle goes this way, so displacement is positive. Even if it comes back also, not now also displacement is positive only, but it is going decreasing, okay? But when it comes back to this position, so displacement becomes zero. But when it goes back towards negative x-axis, the displacement becomes negative, okay? So displacement may be positive. See, these questions may arise, okay, from these points. Then finally, what we can discuss in general, distance is greater than magnitude of displacement. Because you see, if you say some ordinary path, okay, so it is the ordinary path only, okay, here it will be maximum, okay, distance is more than the displacement, okay? But when it will be equal, do you think, can you try to answer when the displacement distance, magnitude of displacement and distance will be equal? Can you answer? Say you, if you start moving, so when the distance and displacement will be same, in which case?
So when we will be moving along a straight line without turning back.
If you move on a straight line without changing direction, means if you cannot come back, okay, so we should better say unidirectional motion, okay? If you keep on moving in the same direction, then distance and displacement will be same. But if you come back, then of course they will not be same. Displacement will go on decreasing, but distance will go on increasing only. Great, 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 great. Nice. So in unidirectional motion, distance and magnitude of displacement are equal. Please write all these things, and lot of questions can be framed from these concepts. So you keep on thinking also what sort of questions can be asked, okay? What sort of questions can be asked? You please think. And once you have written, just let me know. This is just the beginning, okay? First class of kinematics. Remember, in every NEET exam or even JEE also, okay, kinematics plays a important role, okay? So just focus on the target exam only, okay? we are preparing for that. Each and every class is important, each and every hour is important, okay? Each and every concept is important. So now you are discussing displacement, distance. We are going to ask some question also, okay? So on that spirit only you have to keep on studying, okay? Spirit should be same. Well, now what is position vector? Okay, because we need to find out the displacement vector also. That is why actually first we understand what is position vector. Say you know the coordinate of a particle. Okay, I have taken x and y axis. Okay, say I know the coordinate of a particle. Say this is something x y. Okay, the coordinate of the particle. So if the coordinate of the particle is x comma y, then that the vector joining the origin and pointing towards to the particular point. Okay, this is called the position vector actually. Okay, here r is the position vector, but how can I write r? See, if coordinate of a particle at p is xy, then its position vector is written as very simple xi cap plus yj cap. If it has third coordinate also na z, so it will be zk cap. Okay, say the coordinate of the particle is 1 comma 2 comma 3, so position vector will be 1 I cap plus 2 j cap plus 3 k cap. Simple. If the position vector is 1 comma minus 2, then the position vector will be 1 I cap minus 2 j cap. That's simple. As simple as that. Okay. So this is the position vector. Means if you know the coordinate, you can easily write the position vector. Or if you know the position vector, you can easily write the coordinate. Well, this is coordinate x and these two are the coordinate. Okay. Please write it fast. Now I'll discuss displacement vector. Okay. Say the particle is going from one point to another point. Okay. Say this is the point P and the particle is going to this point. Okay. So obviously this point, say this point is something Q. So it will have some another coordinate, na? Like this x2 comma y2. Okay. So this is x1 y1. I'm going to discuss this. Okay. Displacement vector now. Now please write displacement vector. Actually, displacement vector is nothing but final position vector minus initial. Okay. Remember, final minus initial, not initial minus final. If you by mistake write initial minus final, the complete answer will be opposite of that what we want. Okay. So say this is the 2 point. Okay. A point's coordinate is x1, y1, z1, and B point's coordinate is x2, y2, z2. So obviously the A point's position vector will be, say this is OA. Okay. OA is what? I have already told you that x1 I cap, y1 z cap, and z1 k cap. So similarly, if the particle goes from A to B, so B point will have some another position vector. Okay, say the particle may go in a straight line or it may go anywhere. Okay, in any zigzag path, but finally it settled at B. So from A to B the particle is going. Okay, so B point also will have some position vector. Say the position vector is OB. OB is what? X2 I cap minus sorry plus y2 j cap, then plus z2 k cap. So what is displacement vector? That is very important. This is final vector minus initial vector. Okay, final position vector minus initial position vector. That is very important. The displacement vector is defined as, it is just the definition. AB vector is called displacement vector. Okay, from A to B, from A to B. Okay, this vector. This vector is called displacement vector from A to B. So it will be what? Final position vector. OB is final position vector minus OA. Well, so it means what? X2 minus X1 I cap, Y2 minus Y1 J cap, Z2 minus Z1 K cap. You have to take common. Okay. Already we have discussed all these things in vector. So no need to I think worry. Okay, much. So this is the final position vector. Okay, you can write final position vector as del S also. Okay, or del R also. Yeah, simply S also. a symbol according to you, you can choose. Okay, great. So first question, study the question properly. Okay, draw it in number line, how the particle is moving, and try to give the answer. Okay, I'm giving you some time, no need to worry about it. A particle starts from origin and moves in negative x direction up to the point x equal to -4. It is going left. Say left is negative. Okay, not necessarily that left is always negative, but I am assuming that left is negative. Okay, going up to -4, then taking a u-turn and directly going to x equal to 10. After this, it once again takes a turn and come back to the x equal to 6. So question is, find the displacement of the particle, find the distance traveled by the particle. Okay, remember, distance is actual path length and displacement is final position minus initial position, the gap between final position and initial position. Now the time is yours. Well, let us discuss the solution. Can I? Yeah. Okay. So this is the that one number line. Okay, I am taking at this point x equal to 0, and the right direction is positive x-axis and left word is negative x-axis. Okay. Now what I do first, I go to -4x. Okay, 4 meter, -4 meter. Say 1 meter, 2 meter, 3 meter, 4 meter. Okay, I have gone to this point. Well, so it means this is x equal to -4, means 4 step I have already gone. Okay, so if I need to calculate, it is distance 4 only. Okay, +4. I cannot write -4. Distance cannot be negative, na? So it will be 4 only. Okay, then what I do, I come back to the x equal to 0 from that x equal to -4. Okay, so it means I have traveled +4 more. Yeah, you can send your answer through chat box. Yes. Okay. No issue, no issue, no issue. Okay, sure. Then so it will be what? +4. Okay, then again +4 because I am coming back. Then directly I go to 10. Okay, +10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is the point actually, 10. So that x equal to 10 point is this. It means I have to go that +10. Okay, so +10 again. Then this is not the final point. Na? I have to come back to 6 also. Na? So let me come back to 6. So it means how many steps I have come back? 1, 2, 3, 4 steps. Na? 4 steps I have come back. So here again in that one distance I have to add this 4 also. Okay, 1, 2, 3, 4. So that one distance will be this much only. Okay, so altogether what will be the total distance? 4 plus 4 plus 4 plus 10 equal to 22. Yeah, that's correct. Okay, so 22 is the distance. Then think of the displacement. Pardon?
4 वाला part जो क्यों 4 आया फिर से?
Distance.
हाँ sir.
You see, I am traveling from x equal to 0, then going back to 4. Okay, so how many steps I have traveled? 1, 2, 3, 4. Okay, I have added this 4. Then I come back to 0. 1, 2, 3, 4. Okay, this is 4. Then I gone directly to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10 point. 10. So 10. Then I come back again to 4 steps. 1, 2, 3, 4 steps because I have to reach at x equal to 6. Now finally, I have to settle down at x equal to 6. So 4 steps coming back. So it means everything will be +4 +4 +10 +4. Altogether, it will be 20t. Is it okay? This is the total distance traveled. The journey is like this, journey is like this, journey is like this, journey is like this. Okay, I have started from this, finishing at this, but displacement will be this much gap. This much gap will be the displacement. So what will be the displacement? See, displacement will be x final minus x initial. Okay, this is the x final point. Okay, then minus x initial. So initial point is what? This one is the initial point. So what is the gap? It is 6 minus 0 only. Okay, 6 minus 0. So it will be answer is 6 only. Okay, this is the final answer. So that is one is the well. So can I move to the next question?
Sir, why is the initial 0, sir?
Initial, because I have started from 0 only. Na? A particle starts from origin. Origin means x equal to 0.
Okay, sir.
Okay, initial and final. Finally, where it is settled down. Okay.
Yes, sir.
Okay. Now, let us discuss the next question. Problems on distance and deceleration. See, a particle travels from point A to C along the circumference of a circle of radius r through the point B. Find the distance d and magnitude of displacement d. Okay, the figure is this. So this is the center, this is the circle, and this is the point A. I need to go through the point B and to the point C. Okay, so please you try. Given that radius is r, okay, so answer should be in terms of r only. You need to find out. Remember, the particle starts from A and goes to C, but through the B. Okay. Okay. Let us discuss its solution. Remember, the distance is the actual path length. The actual path length is what? The particle is going from A to B along the circumference. So look at the arrows. Okay. It is going from A to C. So it is the half of the circumference. Na? So you know that total circumference is 2 pi r. So it will be half of the total circumference. So it will be pi r only. Is there any doubt? This is the answer. Final answer is this, pi r.
No doubt, sir.
Okay. Then what is the displacement? The initial point is A and the final point is C. Initial point is A and the final point is C. So it is nothing but the diameter only, na?
2R.
So 2r. Yes, that answer is 2r. Magnitude of displacement is 2r. So there enough. You got the answer. Okay. In sometimes it may be you may be asked the ratio also. Find the ratio of distance to magnitude of displacement if they ask like this. So it will be what? Pi r by 2r also. It means it will be pi by 2. That may be also additional question of that way it may be framed. But now they are not asking like this. So that is why our answer is distance is pi r, magnitude of displacement is 2r. Say if the particle goes from A to B only, so what will be the answer? Let us see. Okay. A particle travels from point A along the circumference of the circle of radius r to the point B only. Say now it is not going to that diametrically opposite point. It is going to the B point only. Okay, at some 90 degree you can say. Okay. So this is 90 degree. Okay. Means you can say that quarter of a circle. So what you need to calculate, find the distance d and magnitude of displacement. Okay. Please again 2 minutes for you. Please try. Remember, distance is actual path length and displacement is the segment of line between starting point and final point. Remember, distance is actual path and displacement is the shortest path. Let us try. Solution. Distance, you see, from A to B, it is 1/4 of circumference 2 pi r. No? It is nothing but 1/4 of total circumference. Total circumference is 2 pi r. So it means pi by 2 r. It will be like this. Okay. The distance will be what? Simply pi r by 2 only. And displacement magnitude is what? From A point to B point. Na? You have to that one join a line only, nothing else. Because these two are perpendicular only. So it is nothing but, you see, this is also r. This is also r. This is also r. So this is Pythagoras. You apply Pythagoras theorem. It will be root 2r only. So simply r square plus r square root 2r, nothing else. Okay. One more way you can solve this problem. Say take this as origin. Okay. Take this as x-axis. Take this as y-axis. Okay. So what will be the displacement? You see, displacement is nothing but along x-axis ri cap, and along y-axis it is rj cap. Okay. And you know how to calculate the magnitude of displacement. It is nothing but x component square plus y component square. So that way also you are going to get under 2r only. Okay. Okay, please try this question. A man travels 5 meters. Okay, on a field, you imagine. A man travels 5 meters towards the east. Then 5 meters towards north. It means he takes 90-degree turn towards north. Then climbs a vertical tree. That is also 90-degree turn up to 5 meters. Find the distance traveled and magnitude of displacement. Okay. So what is the total displacement, magnitude of displacement, and total distance? Again, I am saying distance is actual path length and displacement is the separation between starting point and the final ending point. Final end point. Let me discuss the solution. A man travels 5 meters towards the east, then 5 meters towards north, and then climbs a vertical tree up to 5 meters. Find the distance travel and magnitude of displacement covered. Okay. Anyway, let me draw a try to understand visualize that one. Okay. We try to visualize the picture. Say the person is going 5 meters along the east. Okay. Say I am taking this direction as east. Say this is east and this is north, and vertically upward it is that up. Okay, u. So he is going 5 meters towards the east, then takes a 90-degree turn towards the north. Okay, that again 5 meters. Remember, this is again 5 meters. Remember, this is 90-degree actually. Again, he climbs a vertical tree. Okay, that is also 5 meters only. So means finally he starts the journey from this point and ends at this point. Okay, it is, you can say, the diagonal of the cuboid only. Okay, that is the final displacement. But if we ask distance first, So distance is nothing but just addition of all these things, okay? That is 5 plus 5 plus 5, okay? So that is nothing but 15 meter, okay? Distance is 15 meter only. But displacement is the diagonal of the cuboid. So displacement is what? And you know the diagonal of cuboid is nothing but length square plus breadth square plus height square. Na? So you can write 5 square, 5 square, 5 square. It will be actually root 3 5, okay? Because it is nothing but 3 times 5 square. Na? Sorry, 5 root 3, 5 root 3. The displacement will be 5 root 3 only. The length of this diagonal will be 5 root 3. Diagonal of the cuboid. And one more thing, you can say that the displacement vector as 5I cap. If you take east direction as x-axis, then 5j cap. J cap means along the that one north direction, and 5k cap. K cap means vertically up direction, means z-axis. So say this is the vector form of displacement, but we are asked to calculate the magnitude. So magnitude is nothing but this is square, okay? This is ax square or dx square, you can say, okay? If the vector is d, so there is 5 square, then dy square means y component, then z component, okay? Again, it is same thing, 5 root 3 only, okay? Whether you go with that diagonal of a cuboid concept or you go with that vector component resolution, okay? Magnitude calculation of a vectors, of a vector. Hope it is understood. Any doubt?
No, sir.
Okay.
No, sir.
Okay, great. Okay. Can you try to give answer? Out of the 4 options, which one will be the best?
May or may not be 0.
If displacement of a particle is 0, displacement is 0, the distance covered must be 0, may or may not be 0, cannot be 0, depends upon the particle. So out of the 4 options, which one is be correct?
B, sir.
B. Absolutely correct. Absolutely correct. Particle is stationary. It means displacement is 0. So then distance also will be 0. But if the particle is moving and coming back, so displacement is 0, but distance is not 0. Na? So there is a may or may not be 0 is the answer actually. If the distance covered is 0, then displacement must be 0, may or may not be 0, cannot be 0, depends upon the particle. So out of the 4,
Must be 0.
okay. If the distance covered is 0, the displacement must be 0. Yes, that is also absolutely correct. Okay. It will be must be 0. Next question. Okay, that is a little bit similar. I have already discussed. So it will be the last question of today. Okay. And I am going to wind up the class discussing this question only. So the question is, a body moves 4 meters towards the east. Okay, similar actually, similar type question. Okay, say this is going 4 meters towards east, then 3 meters towards north. So remember, this is 90 degree. Okay, this is 90 degree. Then the displacement and distance covered. So distance will be,
Sir, distance is 7 meter and displacement is 5 meter.
distance is 7 meters. Only one option is there. Okay, so automatically C will be correct because distance is 4 plus 3, but displacement will be just 5 because Pythagoras theorem. Na? So this, that is equal to what? Under root 4 square plus 3 square, which will be equal to 5. Okay. Okay, guys. So to on that note, I am going to wind up today's class, and in my next class, we are going to discuss about the speed and velocity. Okay, our next concept will be speed and velocity. Today's distance and displacement is over. Okay, next class will be speed and velocity. On that note, saying goodbye to all. Okay.